Okay, so I decided to do my presentation on nuclear energy. Okay, so you first have to understand that everything's made of atoms. And with an atom, you have your nucleus, which consists of your protons and neutrons, and going around this nucleus is your electrons. And under certain situations, you can split apart an atom, or you can combine this together, and with the atom's mass, you can create pure energy. So, and when this happens, this is under nuclear power plants. And so a fun fact is that today nuclear power plants worldwide produce enough electricity to power an average of 200 million homes. And so I did not say that with this energy, this can be used to create electricity. So, okay, first is fission, and this is when you have a large atom and you split it into two smaller atoms. And normally uranium or plutonium is used, and this is because these two atoms, they're very large and they have a weak force, so they can be split apart easily. So if we look at this diagram, what happens is you have a bunch of neutrons being shot at your uranium, and one of the neutrons hits it, and it splits into two equal masses of two different atoms. And then here you have your energy, and then here's the neutrons coming from these two to balance it out to make it equal. And this is done, and this is where my video comes in, and this is done in your nuclear power plant like this.
In a pressurized water reactor, enclosed in three separate but interacting loops. In loop 1, water becomes intensely hot as it absorbs heat from the energy of nuclear fission. But because it is under very high pressure, the water doesn't boil and remains a liquid. Pipes from loop 1 wind through a steam generator tank that is part of a second, lower pressure water loop. Heat from loop 1 boils the water in the steam generator, and the energy from the steam powers turbines that drive electricity generators. The steam is then cooled and condensed in a heat exchange with a third water loop, which carries water from the cooling tower. The liquid water in loop 2 then returns to the steam generator where it is reheated and the cycle continues.
Okay, and the water that is heated with this in the system, it's heated to about 520 degrees Fahrenheit, so it's very hot. And then, as it said, it creates your electricity. Okay, and so another fact with uranium is 1 pound of uranium has as much energy as 3 million pounds of coal. So you can see why this is one of the options that people look at for energy, or electricity, excuse me. Okay, and so the complete opposite of fission is fusion. And this is where you have two small atoms and you combine them together to make a big atom. And as you see here, you have your two small atoms and they're combined together, and then once again, this creates your energy and your waste product, which is typically helium, and then your neutrons that are, separated from this. But fusion is not commercially developed yet. A lot of people are working on making it, real, because it's such a good way to use or a good way to produce energy because the pollution is so low. Okay, so the capability of nuclear energy. So one, it's very sustainable, and if we look at table 1, it shows what 100-watt light bulb, how long it could power, how many days it could last using 1 kilogram of these various fuels. So if you look at wood, it's 1.2 days, or coal, it's 3.1 days. But if you look at any of these uraniums, it's a whole lot longer than your typical coal or wood. And so uranium is very abundant as well. So there's a lot of uranium in the ocean, and at low concentration you can take it out, but it's very costly. So that's sort of the negative side of doing that. Another capability is that we could be very energy independent, meaning that countries rely very heavily on getting our fuel from other countries, and if we had nuclear power plants in your own country, then you would be more independent and not have to rely on these other countries. And just thinking about if you used electric cars or these hybrid cars, that it would already take out, powered by nuclear power plants, it would already take out a lot of the oil that's used from vehicles. Okay, and the third capability is that it's very ecological. So nuclear energy doesn't emit a lot of pollution into the air. The only thing that comes out into the environment is hot water. Very little CO2 is produced, but there is some CO2 that comes out of if you're like mining or construction, but it's a whole lot less than if you were using coal. And then we'll move on to the problems. Okay, so one of the problems with nuclear energy is the biological damage, meaning that when you split apart an atom or combine it together, the energy to make energy, what's released is particles, and they can be left in energetic states. And sometimes the energetic states, it can take forever for it to decay to stability. So, and if you have these particles that are released into the atmosphere, they must be controlled or it can be a mess. And you have to have these facilities that control them, and that can be costly to build those, which leads me into the next problem, which is cost. So the upfront cost of building a nuclear power plant is a whole lot more than if you were building a coal plant. But after the plant's built, it's a whole lot less than using other fossil fuels. So as of right now, the upfront cost to build these nuclear power plants is $9 billion, and I'm sure that's gone up because that was in 2008. Okay, so the third problem is the major accidents. There's been 3 commercial accidents that have happened with these power plants, and one is the Chernobyl accident, which happened in the Soviet Union in 1986. And what happened was there was a flaw in the nuclear reactor in the design, and they had these people that were not trained very well, and a steam explosion happened, and the fire started burning, and it lasted for about 9 days. And so with that, it brought a whole lot of radiation and a whole lot of cancer cases, and the cases are still being worked on today. So here's what the actual site looked like, and this was after 2 days after the fire had went out. So you can see it was very bad. And then this was a town 2 miles over. I would tell you the name, but I can't pronounce it. It's a funky name. And this was a kindergarten classroom, and all the radiation and everything that happened, it just, it was a whole lot of mess. So my resources, and to end this, nuclear energy has not been fully developed, and it's been a work in progress, and they're still not all the way there yet, but it is very big potential that this could be a future energy resource that's, replaces oil or coal. And that's everything.